Take a look around. Everything you see, touch and feel is made of super tiny pieces called atoms. Atoms are like the basic Lego blocks of everything in the universe. They're incredibly small, but super important for understanding how everything works. From the air we breathe to the stars way up in the sky, atoms are everywhere. They join together to make bigger things, just like Lego blocks can build a castle or a spaceship. These combinations make all the different stuff we see in the world. Atoms stick together to make molecules, from simple things like water to complicated things like DNA. The way atoms connect determines if something is hard, like a diamond, or flows like water. Studying atoms is like studying the universe itself. By understanding atoms, we learn the secrets of stuff and how it behaves. From the smallest pieces to the biggest galaxies, atoms connect us all. They're like the common thread in the giant tapestry of the universe. The idea of atoms started way back in ancient Greece. A guy named Democritus thought everything was made of tiny pieces he called atomos, but he didn't have any proof. It wasn't until the 1800s that a scientist named John Dalton did experiments and figured out that all stuff is made of atoms. He also said that different elements are made of different kinds of atoms. Then in the 1900s, scientists discovered even smaller pieces inside atoms, protons, neutrons and electrons. This led to something called quantum mechanics, which explains how stuff works at the atomic level. Today we have giant machines called particle accelerators, like the Large Hadron Collider, that help us study the tiniest bits of matter. Learning about atoms has helped us invent cool things like nuclear power and electronics. Even though we've learned so much, atoms are still amazing and inspiring. They remind us how big and complicated the universe really is. To understand atoms, we need to go back to the very beginning of the universe. 13.8 billion years ago, the Big Bang happened. It created a super hot, super dense soup of energy and tiny particles. As the universe cooled down, these particles, called quarks, joined to make protons and neutrons. About 380,000 years later, electrons joined with protons to make the first atoms. These first atoms, mostly hydrogen and helium, became the building blocks for stars and galaxies. When atoms formed, it was a big change. The universe became see-through and light could travel freely. This created something called the cosmic microwave background radiation, which is like a faint echo of the Big Bang that we can still detect today. Atoms exist because of a perfect balance of forces and constants. These fundamental forces, like gravity and electromagnetism, are just right for atoms to form. If the strong nuclear force were a little bit weaker or stronger, atoms wouldn't exist as we know them. The weights of the tiny particles inside atoms are also really important. Even small changes in these weights would mean stable atoms couldn't form. This perfect balance makes us wonder about the universe. Some scientists think the universe is made just right for life because we are here to see it. This is called the anthropic principle. Others think there are many universes, each with different rules, and we just happen to be in one, where atoms can exist. Even though we know a lot, atoms are still a big mystery. Studying atoms has helped us create new technology and continues to change how we understand the universe. Scientists are exploring even smaller particles like quarks and gluons to understand the strong force that holds atoms together. They are also looking into dark matter, a mysterious substance that makes up a lot of the universe's mass. Dark matter might be made of exotic particles, which could teach us even more about the universe. Wanting to understand atoms shows how curious humans are. The more we learn, the more questions we have, reminding us how vast the universe is. Our journey of discovery never ends, and atoms keep inspiring us to explore our place in the universe.